All right, so now we're starting chapter 7, which will be on shifting and scaling functions. Section 7.1 specifically covers horizontal and vertical shifts of functions. Okay, so let's go ahead and get started. Just a little recap from what you should have watched in the lecture video. If we are shifting left, or I'll do right first, shifting right, we subtract from input. So we'd have g of x equals f of x minus whatever value. I'll put k, or actually I'll put h. Whatever value we're shifting horizontally. All right. If we're shifting left, we add to input. So we'd have g of x is equal to f of x plus h. Okay. Next, if we are shifting up, we're going to go ahead and add to output. And all that means, because that could be a little confusing, but oops. Nah, I wrote it with a weird space at first, and then I just wanted to fix it. There we go. If we're adding to output, that could be a little bit confusing because we're changing the function, but we have g of x is equal to f of x. So nothing is happening to this input. And then we add the k value, the amount that we're shifting up. And lastly, if we shift down, we're going to subtract from output. So we'd have g of x equals f of x minus k. Okay, so when we say add and subtract from the input, we mean that we're going to directly add or subtract from our x value. So it will be in parentheses with our x. It's going to attach directly to the x. When we say that we're adding and subtracting to our output, what's happening is we're adding and subtracting to everything that happens after whatever the function of f does. So g of x here is the function of x. First, whatever the function of x is, whatever you can imagine it to be, is going to happen to x. And then the output of this f function will we then add the k value or subtract it. Any questions on adding and subtracting to the input versus the output?
So far, so good.
All right, good. So now I have a ton of examples for us to work through. So problem 1, give the formula for the function g of x that satisfies each of the following. The graph of g of x is the graph of f of x shifted down 7 units. So it's whatever's happening to f of x, but we're shifting it down. So we'll have g of x is equal to f of x. Since we're shifting down, we're going to subtract from the output. So we'll have f of x minus 7. Any questions there?
If we're doing it on loose leaf, is it okay if we just write the answer for this?
Yes, of course. Yep.
Okay.
For B, we have the graph of g of x is the graph of f of x scale or shifted up 1.5 units. So we'll have g of x is the graph of f of x, and it's shifted up 1.5 units. So we're going to add 1.5.
Yeah.
Do you have a question?
No, never mind. Thank you.
Okay. The graph of g of x is the graph of f of x shifted to the right 2 units. So now we're getting into territory where we have to be careful. We have left and right being mixed in. So remember, left and right, we add or subtract to the input. So we'll have g of x is equal to f of x. We're shifting to the right, so that tells me to subtract minus 2 close parentheses. So what's happening here is x minus 2 is being plugged into the function f as the variable. So x minus 2 is one complete, complete variable or input. It's a complete input that we plug everywhere into f, whatever f may be. Any questions there? Okay, moving on to problem D. Holy cow, that wind is crazy. I don't know if you guys could hear it, but it's crazy. All right, problem D. The graph of g of x is the graph of f of x shifted left 3 units. So we have that g of x equals f of x. It's being shifted left 3 units, so it's f of x plus 3, close parentheses. So x plus 3 is the input value that we're using. Any questions there? All right, the next couple ones, we're going to be shifting either left horizontally or we're going to be shifting horizontally and vertically. So we're going to have to change the input and the output. We're going to have to go ahead and shift that. So this first one, the graph of g of x is the graph of f of x. So g of x is the graph of f of x shifted up 2.3 units into the right 6 units. So what am I adding or subtracting to my input?
You're subtracting 6.
Good, we're going to subtract 6. We're subtracting because we're moving to the right, and we chose 6 because it's 6 units. And now what am I adding or subtracting to my output?
You're adding 2.3.
Good, we're adding 2.3 because we're shifting up, and then we have 2.3 because we're shifting up 2.3 units. Any questions there?
So you don't need parentheses around the 2.3?
Correct, we don't. And the reason we don't is because we want to make sure that our input value happens. So our input is being shifted to the right 6 units, and then we're going to add to that output. So we don't need parentheses around this. Okay. The graph of g of x is the graph of f of x shifted down 1.63 units into the right 0.5 units. So g of x is equal to f of, we're going to the right 0.5 units, so am I adding or subtracting?
Subtracting.
Subtracting.
Good, minus 0.5, and then we're going down 1.63 units. So what do I do? What am I adding or am I adding or subtracting to my output?
Subtracting.
Good, since we're going down, we're gonna go ahead and subtract 1.63 units. All right, next we have g of x. The graph of g of x is the graph of f of x shifted up 12 units into the right 10 units. So what's happening to my input?
Subtracting.
Good. We're going to subtract how many units?
10 and then add 12.
Good. Okay, and then lastly, the graph of g of x is the graph of f of x shifted down 3.2 units and to the left 7.1 units. So we have g of x is the graph of f of x shifted, we're going to have left 7.1, so we'll have x. This time it's plus 7.1 because we're going to the left, so we use addition, minus, from the output we subtract 3.2 units. Any questions there? Okay, I'm hoping maybe some of this looks familiar to you. We have seen shifted and scaled functions. We just haven't called to them that. But if you remember back with quadratic functions, if we had y equals x squared, right? That's our standard quadratic equation or function. It's not, well, it's technically in standard form, but this would be directly, you know, the graph that goes through, the vertex goes through the origin. This is y equals x squared, x, y, right? But remember, we also talked about vertex form. So in vertex form, we had y equals x minus h squared plus k. Can someone tell me what is happening? Oops. Dang it. Can someone tell me what's happening to our input value?
It's to the right.
Good. It's being shifted to the right by h units. And what's happening to the output value?
It's going up.
It's being shifted up k units. Good. So the output, oops, we had x, y, we'll say this point here, we'll call it hk, is now a new quadratic or graph of a quadratic function. And it's, so our vertex form is really just a transformation on our, on the original or standard quadratic function with no coefficients. Does that make sense?
Yeah.
Okay. All right, problem 2. Identify the function being transformed and describe the transformation being applied to it. Okay, so in order to look at these, you kind of have to look at it and get rid of everything that's being added or subtracted. And that's how you then determine what type of function it is. So this first one here, we have f of x is equal to x plus 4 squared. If this was plus 0, so if it was just x squared, what kind of function would it be?
The parent function.
It's the parent function, but the parent function is also, this one happens to be quadratic. And since the parent function is quadratic, the transformed function is also quadratic. Does that make sense?
Yeah.
Okay. So it's quadratic, and now we have to describe the transformation. So our input, the input value is being added to 4. So we're adding 4 to the input value. So am I moving horizontally or vertically?
Horizontally.
Good, we're moving horizontal, and it will be left or right?
Left.
Left. And how many units?
4 units.
4 units, good. Okay, problem B, we have g of t is equal to e to the power t minus 3.2. If I got rid of this 3.2, pretend it's not here, what kind of function is the parent function?
Exponential?
Exponential, good. And since the parent function is exponential, what type of function is our transformed function?
Exponential.
Good. All right. And are we shifting left, right, up, or down?
Down.
Shifted down. And how many units? Someone who hasn't spoken today.
3.2 units.
3.2 units. Thank you. Any questions there? Okay, problem C, power function. H of t, oh, I just gave you the answer, but h of w is equal to the square root of w minus 4.1 plus 5.2. What type of function is this?
A power function.
Yes. And can someone explain why it's a power function? Because it doesn't look like our standard power function.
The square root is over the variable minus 4.1. So that's, you'd put w minus 4.1 in parentheses, and then it would be to the 1/2 power.
Good. We could rewrite this as w minus 4.1 to the power of 1/2 plus 5.2. And when we go ahead and rewrite that, we can now see that we have a power over our variable, so it's a power function. Good. All right. Are we shifting left to the right, or up and down, or both?
Is it right and then up?
Yep, we're going right and up, so we're shifted. How many units right?
4.1.
4.1, and then up 5.2 units. Okay. Any question there? Okay, moving on to D. Y equals 0.9 to the power of t plus 1 minus 3. Okay. What kind of function is this?
Is it exponential or no?
Yes, this one is also exponential. The parent function is, let's just say f of x equals 0.9 to the power t. Right, so this is the original function. And then what we're doing in this one is we're adding 1 to t and subtracting 3 from the total. So it's an exponential function and it's shifted. First, is it shifted left or right?
Left.
Left 1 unit, and then shifted left, up or down?
Down.
Down 3 units. Okay. Any questions? Okay, moving on then. Okay, use the graph of f of x below to sketch the graph of the following transformations of f of x. So, I don't know if you only have pencil available, just do like 1 dashed, 1 dotted, and 1 solid line. you'll have to draw the original graph. So why don't you guys go ahead and draw that, and then let me know once you get that done, and then we'll start talking about these transformations. Are you guys just about ready to go ahead and start, or are you still working on drawing the graph?
I'm good.
Good.
All right. We'll go ahead and get started then. So we are transforming y. We have y equals f of x plus 1. What is happening in this transformation?
It's going up 1 unit.
Good. We're shifting up 1 unit. So all we have to do to our graph is we're going to take a couple points. So I'll pick a few points that we'll just graph every time. I guess it'll be all the points. Almost all the points. Okay. And we're going to go ahead and shift them up 1 unit. So this gets moved to here. This gets moved to here. Also gets moved to here. Move to there. That gets moved to there. And that gets moved to there. So then we could go ahead and draw the sketch of the graph. And that's our first transformation. Notice if we were to look at all of these points, so here we have the point 1, 3, here we have the point 2, 2, here is 3, 3. So if we just look at these three, and they'll get our point across still. The point 1, 3 becomes the point 1, 4. The point 2, 2 becomes the point 2, 3. The point 3, 3 becomes the point 3, 4. When we talk about coordinates, if we have x, y, what is this x value we call the input, and the y value is called the output. Well, they have many names, right? Independent, dependent, input, output. But notice that when we shift up 1 unit, only the output changes. So that makes sense that we're only going to add 1 to the output of f of x. Okay. Any questions on that? Okay. Graph of b. What is happening to the function? How is f of x being transformed in part b?
Right one.
Good, it's being shifted to the right 1 unit. So this now moves to here. This now moves to here. This point moves to here. This point moves to here. This point moves to here. And this point moves to there. So we go ahead and draw it. And it goes there. Okay. Again, if we were just to look at the points that I just drew for the new graph, the purple graph, we again have the point 2, 3. We have the point 3, 2. We have the point 4. How far are we? 3. We have the point 4, 2. Oh, 4. I can't see. 4, 2, 4, 1. Something a little below 4, 1. But the point is that for each point, we went from the point 1, 3 to the point 2, 3. We went from the point 2, 2 to 3, 2. We went from 3, 3 to 3, 4. We went from the point, yeah, that's why these last 3 aren't exactly on a thing, I don't think. Doesn't seem like it, at least. But you could see with these points that are clearly at on a perfect point, that's not a fraction, we can see that all of our x values are being pushed to the right 1 unit. And the reason it's subtraction, if I say just memorize that. If you want to know why, you could feel free to stay after class. I can't necessarily explain it. Well, I can't explain it. I don't want to right now because I don't want to confuse some people that might not be understanding it. But if you are curious as to why, stay after class and I'm happy to answer that for you. Okay. Lastly, graph of C, we have f of x equals x plus 1 minus 2. What is being what shifting is happening here?
Shifting left 1 unit, down 2 units.
Left 1 unit and down 2 units. Good. So we'll take each point, like the point 1, 3. We'll go left 1 unit and down 2 units. And then take the point 2, 2. We go left 1 unit and down 2 units. The point 3, 3. We are going to go left 1 unit, down 2 units. This next point, we'll go left 1 unit, down 1, 2-ish. I'll put it here just to make it easier. Yeah, and then I'm just going to do this last point here, left 1 unit, down 1, 2. It'll actually end up being down here. So when you go ahead and draw this, it's something like that. And it's okay, that just goes a little off the grid. As long as you have the points up to this point, if you only drew your axis as minus scaled, then that's fine. All right. And again, these points, this point here was 1, 3, but it was shifted left 1 unit, so it became the point 0. And then it was shifted down 2 units, so it became the point 0, 1. All right. Any questions on this stuff? I'm graphing these. Okay, moving on to the last page then. Problem 4, now we're going to use the table of values, f of t shown below, to write the table of values for the transformation y equals f of t minus 2 plus 6 of f of t. So we have t and f of t. You don't have to, if you're writing on loose leaf paper, you don't have to write the original table out. I just need the table for your answer. Okay, so what transformation is happening in y?
You're going, well, you're adding 6.
Yeah, we're adding 6. So does this 6 tell me to go up or down or left or right?
Up.
Good, we're going up 6. And what is happening? What other transformation is happening?
Right 2.
Good, and right 2. So this value of 0, this value of 0, we have to shift it right 2. So 0 now becomes the 0.2. The 0.5, we have to shift it to the right 2, so it now becomes the 0.7. The x value 10 shifts to the right 2, so it'll now be 12. And 15 shifts to the right 2, so it'll be 17. Any questions on shifting our input, our t value? Okay, shifting our output now, we're going to have to add 6 to each of these. So 6 plus 0.1 is 6.1, 6 plus 0.2 is 6.2, 6 plus 0.4 is 6.4, 6 plus 0.8 is 6.8. Okay, any questions there? Okay, then our last problem, an application, a word problem. The function h equals f of t gives the temperature in degrees Fahrenheit of water in a spa t minutes after the spa heater has been turned on. Okay, so what's happening here, and just for you visual learners like me, on our axis we have the input value is temperature, measures t or with variable t, and then our input is not temperature. Our input is time. Is the time, and our output is the temp. And we're using h as that variable, big H. So for A, we want to write the formula G of T that represents the temperature in degrees Fahrenheit of water in the spa if the spa heater is turned on 15 minutes earlier. So we're turning it on 15 minutes earlier. So that means that our input is going to change because time is our input variable. So we'll have g of t is equal to f of t, and since we're turning it on 15 minutes earlier, 15 minutes earlier tells us to move left 15 units for 15 minutes. So it's going to be plus 15. And that's our transformation there. Any questions? Okay, for B, write the formula of the function h of t that represents the temperature in degrees Fahrenheit of water in the spa if the temperature of the water in the spa were 5 degrees warmer at the time that the heater was turned on. So if it initially was turned on and it was whatever, 0 degrees down here, but now this part is saying, imagine that it's 5 degrees warmer when it's turned on. So say this is 5, it starts out here. So our initial value, I don't know what this function looks like. It could look like anything, but the initial value is 5 now. So we'll have g of t is equal to, and since the initial value is 5 degrees warmer, it's going up 5 degrees. So we'll have g of t is equal to f of t, and then add 5 to that output to shift it up. Any questions there or on anything else from today? If you don't have any questions, you are free to go. Have a great rest of your day. I'll see you Friday. Don't forget to submit this.
Thank you, you too.
Thank you.
Thank you.
You're welcome.